Hello, I'm Poornima Nayar, and I will be talking about GraphQL in .NET Core today. If you don't know me, I'm a freelance .NET developer based in Berkshire, UK. I'm a Microsoft MVP for developer technologies, and I do a lot of work with Umbraco CMS, which is a .NET-based open source CMS, and I've been their MVP for the last 2 years. Non-work me, I have a 6-year-old girl who I spend most of my time with. I spend a lot of time reading. I love fiction, and I'm also learning Carnatic music in my spare time. And I've been doing that for the past 3 years. And that's my Twitter handle, should you wish to connect with me. Without much delay, when we talk about GraphQL, it comes across as one of the cool kids on the block when we talk about APIs. So GraphQL is a query language for APIs, and it's backed by a runtime for fulfilling those queries. And all this is based on your existing data. GraphQL has no concern about where the data is stored. It only presents you with the data. At its simplest definition, GraphQL is all about specifying types. And as a consumer of the API, I ask for specific fields on specific types, but there's a clear hierarchy of the types. GraphQL is a specification, which means various programming languages, which has various implementations of GraphQL, tries to fulfill that specification. And when GraphQL presents data as a graph, because data generally can be viewed as a graph of relationships. And GraphQL lets you traverse that data graph and extract parts of it. Why did GraphQL come into existence? Facebook actually introduced us to GraphQL sometime in 2015, although they actually discovered or developed this as an answer to an issue they faced internally. So when Facebook introduced their first mobile app, it got banned because of the way it was draining out the battery life of the user as well as consuming the network bandwidth. So a scenario of some sort of like this was happening in the app. So it would ask my user ID over a REST API. And then from there, it would try and probably load the events. And for each of the events, go and fetch the event details. Probably have friend suggestions, friend birthdays, and in turn go and fetch the details of each of these users. So it's like a cascading effect, a pyramid of REST API calls building up a multitude of them. And it introduced overfetching and underfetching and the N+1 problem. Overfetching means I am actually getting or fetching a lot more data than I actually want to use, and using a tiny portion of it, discarding the rest. For example, I might be just wanting the name, the profile picture of a person, but I get the entire user data about a particular user and just use the 2 fields, discard the rest. Similarly, we have underfetching as well. So underfetching goes hand in hand with overfetching. That underfetching happens because at no point in time, I have all the data that can be brought back to me with a single API call. So then I reach out to all these APIs, and that results in overfetching. And you might have noticed the N+1 issue as well, where, for example, to load events, n number of event details, I was making N+1 calls. So Facebook engineers had a thought over it, and they came up with an answer, which is GraphQL. And with GraphQL, we don't have multiple or million REST API endpoints. It is a single but smart endpoint that takes in complex queries and builds the data output for you. And the fun fact is that the response that you get from the API mirrors the query. So clients or consumers specify what they want, and they get exactly what they want, and that's what GraphQL does. So if you look at the query here, I'm asking for a course with ID 1045, asking for some fields, and I don't get anything more than what I need. So that's one of the fantastic features about GraphQL. So that's exact fetching. I can even ask for nested data, which you can see here with the enrollments. I'm asking for students who are enrolled to a particular course. I get the student details as well. So it builds a data graph for you. If you're after an analogy, GraphQL is like a smart person who tells you, hey, Give me the address of a pizza place, I'll get the pizza for you. Give me the address of the grocer, I'll get the list of items you want. Give me the address of the dry cleaners, I'll get what you want from there. While as with a REST API, you probably need to go to each of these places one by one. So with GraphQL, the address where to fetch it from is important. And the list, you tell it what to do, and GraphQL does exactly that. Some of the features, if I'm to talk about GraphQL, it's strongly typed. There's a strongly typed schema at the heart of GraphQL, which does all this heavy lifting for you. It's a specification, as I said before. It is introspective. GraphQL has this feature whereby you can query itself. So you can understand the types in a GraphQL API endpoint by querying itself. And this has led to some fantastic browser-based IDEs for testing your GraphQL queries. And it are also tools which can auto-generate documentation about the API for you. All these IDEs support documentation as well, which we will see in a bit. Your objects in the data graph will have relationships, and the schema or GraphQL follows that hierarchy. So that hierarchy is respected, and you get a JSON response that mirrors the query. One important thing to note is that GraphQL is an application layer, so it resides between your existing data source and your client. GraphQL doesn't concern itself with where the data is stored. You just tell it where to fetch it from. So it can be a third-party REST API service, it can be a database of your choice, or it can even be a GraphQL service. You can connect to multiple GraphQL service and then have a gateway-like architecture. If you are thinking about versioning in GraphQL, you're getting it wrong, because GraphQL doesn't have the concept of versioning. The reason being, clients ask for what they want and they get exactly what they want, which means the API can progress at its own pace and the client can progress its own pace, which means we can get rid of the versioning. And there's also a feature by which you can deprecate fields in GraphQL, which means that you mark a field deprecated, the client can stop using it, and then it can be removed. And the only time when you can actually break a GraphQL API and the connection between the client and the server is when you remove a field purposefully, which is being used. I don't think we would do that. And finally, GraphQL is transport layer agnostic. Even though HTTP is the most popular way of using GraphQL, it is transport layer agnostic. There are some big players in the market with GraphQL these days. Facebook, of course, started it. GitHub, Pinterest, Shopify all have GraphQL APIs which supports developers. So time to talk about the GraphQL type system. The GraphQL type system is what is at the heart of a GraphQL API and does the magic for you. At the heart is something called a schema. And because GraphQL is a specification, we need a language agnostic way to talk about GraphQL schemas. And a schema definition language or schema language helps you define that schema. And all the implementations in various programming languages lets you define the schema in one way or another. You will see that shortly in my demo. Talking more about schema, schema is made up of types. So the first one is object types, which is a representation of the object or the entities which can be acted upon. And then you have the operation types. There are 3 operation types. The first one is query operation type, which lets you get the data. But unlike REST, where you get the data usually using an HTTP GET, this happens over an HTTP POST. Then you have mutations, which is another operation type, which is for inserting, updating, or deleting data. And then you have subscription for pushed updates. So these makes the types in a GraphQL schema. And types are made up of fields. Each field must have a name because this is the name which will be used to specify or ask for the particular information about a field in the operation that you send in or the call that you sent in. Each field must again have a type. This is the concrete it resolves to. So it can be a primitive data type like an integer or a string, or it can even be an enumeration or a complex object that you define. Literally, one of the object types can be returned as well. And then you have resolvers. Resolvers tell GraphQL where where to fetch the data from, or how to resolve a particular field for the data. And this is how a GraphQL type in SDL looks like. This is my student type, which is a custom or object type. It has fields, ID, first name, etc. fields. They all have types against them, integer, string, etc. There's a datetime one, and there's even a custom one called a list of enrollment type. GraphQL out of the box supports 5 data types: integer, float, string, Boolean, and ID, which stands for unique identifier. But the package for .NET Core, which I'm going to demo today, supports a lot more. You can create your own custom scalars if needed, but GraphQL.NET, the package I'm using today, it helps us with defining a lot more. Usually datetime is one scalar which you need to define and handle on your own, but GraphQL.NET sorts that out for us out of the box. We can have enumeration types. We can have non-nullable fields. So marking of a field non-nullable is done by adding an exclamation mark by the type it resolves to. And you can even have lists. So lists are denoted by square brackets and having the type name within. In my example, enrollments is a list of enrollment type, which could be an enum or even an object type. So today's example, what I have is a EFCO database, which has 3 tables: student, course, and enrollment, with a one-to-many relationship between the student and enrollment, and one-to-many again between the course and enrollment. This is based upon the EFCO tutorial on the MS Docs website, so feel free to have a look at it. And I will expose this over a GraphQL endpoint, and we'll consume that in Blazor. I think it's with Xamarin and Blazor and technologies like that, which is actually helping GraphQL gain traction these days. And it's always good to do some Blazor work. So when we talk about GraphQL in .NET Core, there are 2 implementations. There's GraphQL.NET and a relatively new hot chocolate. That's the package name. That's the implementation called. Both of these have been around for some time. Both of these are open source, and they have strong communities around it. Being open source, feel free to contribute to each of these packages. They need contributors in terms of documentation, code, issue triage, everything. So try and help out if you can. So this defines the API part of it. And then we have clients to consume the GraphQL API. You can go for GraphQL.NET client, which is the client corresponding to GraphQL.NET, or you can use Strawberry Shake, which is again coming from the hot chocolate team. There's no hard and fast rule that you have to use a particular client with the particular API implementation. You can go for one or another. There are also some tools or IDEs which helps us test our queries and a lot more. So these are some of them. Most of these are browser-based. Insomnia and Banana Cake Pop are desktop applications, and Banana Cake Pop is again from the house of hot chocolate chili cream. So all these IDEs helps us with syntax highlighting, IntelliSense, error highlighting, testing our queries, and most importantly, schema introspection and the documentation, which is an invaluable tool. So if you are familiar with Swagger for web APIs, then you would find it very similar, but just that I think the IDEs for GraphQL is a lot more advanced than Swagger. So let's get started. For the GraphQL endpoint, the first primary package to have is the transports ASP.NET Core that installs the HTTP related stuff to our solution. I'm starting off with a empty ASP.NET Core web application. And this package installs the GraphQL package as a dependency. And the GraphQL package is actually the implementation of GraphQL for .NET Core. There's a lot of JSON serialization and deserialization happening, so we need a package for that. I'm using system text JSON, but there's also a Newtonsoft package corresponding to that. And I've also installed 2 playgrounds just to demo it a bit, and I've got that as well. So let's have a quick look at the ASP.NET Core app. So this solution contains two projects. One is my Blazor app, and one is the demo API. The first thing we need to think about when we come to a GraphQL API is the schema. So a schema can be defined like so. It's a class which derives from the schema class. And in the constructor, you provide your query, mutation, and subscription operation types. And we can inject an iService provider and use that to get the service object corresponding to a query or a mutation or a subscription. We'll come back to each of these in detail later on. But before that, I would like to show you the actual models which I'm working on today. So we have a course model with some fields and a navigation property. We have a student class with some navigation property and some fields. And then we also have an enrollment class with some fields and navigation properties. And I also have grade as an enum. I also have repositories corresponding to this for CIUD operations. I have initialized the database with some seed data, all standard EF core stuff. Now, let's start thinking about the GraphQL types. So these are the models I'm going to be working on, but how do we tell GraphQL to use these? And that is done by defining graph types for each of these models. So they are specified here. So for each of my entity, I need to define a GraphQL type, corresponding GraphQL type. And that is done by inheriting a class from object graph type and passing in the base model, which is course in this case. Again, in the course constructor, I can define fields and give it a name and a description. The name, you can override it if you need, otherwise it takes up the name of the property itself. And these name and description comes in the docs, in the playground, so that users can make use of it. If you want to make a field deprecated, this is a way to use it, do it. You can add a reason for deprecation, and that will mark the field as deprecated in the API and in the docs. As you can see, this field does not even exist in my base model. So that's one thing, again, you can do. For example, if you have a first name and last name for a person, you can concatenate it in your GraphQL type as a field and pass it along. Perfectly possible. This is about data loader, which we will talk about later. Similarly, I have types for enrollment as well as student type. In the enrollment type, if you remember, I showed you an enum. So we need a little bit of extra work because we need to tell the GraphQL type that the field which corresponds to the enum in the base entity needs to be served up as an enum type. So for that, I can define a class which inherits from enumeration graph type, passing in the base enum, and describe, give it a name and a description. And in my actual object graph type, which is enrollment type, I can define a field of this particular type. So each field has a type as well. And if you don't define a particular type to a field, what it does is it takes the type of the underlying entity model. Now we need to start wiring up things, a little bit of work in the startup class. I have got my DB context registered here. I've got all my services registered. We'll come back to this a bit later on. The first thing is to register my schema, and that's done by doing like registering the schema using add scoped method. Then we can start registering the GraphQL. So that's done using the add GraphQL method, and I've enabled metrics. So if I enable the metrics, some of the GraphQL playgrounds lets you see this metrics in the IDE. Then I can register my graph types. What this method does is it scans the assembly for all objects or all classes which implements the iGraph type interface and registers that. So which means it registers your operation types for you, your input types, or even your normal entity types for you, object types. Then you can register the system text JSON for JSON serialization and deserialization. If you want error info, detailed error info, that can be done by adding the error info provider. This is for data loader and WebSockets, which we will speak about later. I'm enabling course because I want to query this over a Blazor, from a Blazor web app, which is separate. And then I can start setting up the middleware. Let's first talk about this. We'll come back to this again. Course is again allowed. I need to tell it to register the GraphQL middleware or set up the GraphQL middleware and tell it what schema to use. What this does is it sets up the endpoint for me, and the default path is /GraphQL. So you can override that path and it will set up the GraphQL endpoint at that path for you. I don't have any controllers, but you can define your own web API controllers, deserialize and serialize the query that comes in. You can have your own routing if you want. There's example of this in the GitHub repo for the project. But I'm sticking to plain and simple method here. And then I can register the middleware for graphical, Playground, and I've also installed Altair, which sets up the IDEs for me. So that is the setup about the API. Next is Blazor. We are consuming the API in my Blazor WebAssembly app, and I'm using GraphQL client for it, which I have installed. And I've also got system text JSON, which I'm using for deserializing the data that comes along. And the setup for this is quite straightforward. In the program class, I define a GraphQL client, passing it the endpoint and defining my serializer. And then I can register my iGraphQL client to the services. So that's the setup done. Let's now start talking about the operation types. So we'll see how we can implement or enhance the schema for each of the operation types, how we can build operation or fields around the operations, and then finally consume that in my Blazor web app. So the first one is the query operation type. It's one of the operation types in GraphQL, and it's the top level entry point for read operations, but you read data over a post operation typically. The keyword for querying the data is the query keyword. GraphQL considers every query that comes in as a query by default, not a mutation or subscription. So you can omit that if needed, but it's considered best practice to include that in your queries. What you get back from query is a hierarchical JSON response. And when you make a client call from your app to your server, you can send in 5 queries altogether. And those 5 queries will be executed in parallel for you. You can control all of that, but natively they do parallel execution. They don't wait for each other. So let's have a look at how we can achieve some queries. So in my Contoso University schema, I have my service provider, which gets me a Contoso University query object. So let's go and have a look at it. It is again something which derives from an object graph type. So that's an operation type. And in my constructor, I have fields. So remember a few slides back, I said, types and fields is what GraphQL is all about. So each of the operation is field, and each field has a type, and each field has a name and a description and a resolution as well. So the field type tells it what the return type is. The name of the operation is what I use to specify or get the data. The description again helps to show it. The resolver tells it where to get the data from. So for that, I'm using my repositories for which gets me the data using DB context, standard EF core. Let's have a look at each of those queries now in detail. So there are 4. There's one for getting the courses. There's one for getting a course detail by its ID. There's one for getting all the students, and there's one for getting a particular student details, and each of it returns corresponding types. So the one which specifically has an ID returns a single course type or a student type. Otherwise, it returns a list graph type, which is again a list corresponding to GraphQL. What else? Yeah, now this is all what I need to set up my query. So now let's run some queries now. So this is the IDE that I wanted to showcase today, the GraphQL Playground. There's also Graphical. In fact, GraphQL Playground is based on Graphical. Graphical was the first one to come out. So let's run some queries. Before that, I would like to show you the docs. So as you can see, the operations that I specify come up in course in the docs. And then I have the schema, which is the entire schema that I have specified using my schema class in SDL for you. This is actually the schema definition language. So for each of these queries or mutations or subscriptions, I can then drill down and see what it is all about. So this course says it's a list of course type that gets returned. I can see the description. I can see what the course type is all about as well. So it's quite helpful. And this is all picked up from the name and description that I added to my types, again, which is fantastic because I don't need to worry about my documentation. So let's send in some queries. I've got some queries already saved here, actually. So you start with the query name, the query keyword, and you give it an arbitrary name, which is always considered a best practice. Then I can specify my student's query, which is the query to get a list of the students. And then I can specify what fields I want: ID, first name, last name, email address, and I'm even asking for some related data. And as you can see, it should fetch me the list. And I'm using a bit of aliasing here. For some strange reason, if I as a consumer don't like the name of the query, I can always alias the field. It comes handy when you have fragments and things like that as well, which I'm not covering today, unfortunately, but this is possible. And what it does is then the data graph takes the shape of the alias that I have added. So that is querying a list. Now, if I want to query a particular student detail, I have defined the query again here. We have arguments in our query. Yeah, that's one thing I missed out on. Let me just quickly show you that. To query a particular student or a course type by its ID, I have arguments specified here. Arguments are very similar to primitive, the arguments in any other programming language that you're familiar with. In my case, both course type and student type has an ID, which is a no-null int graph type. And again, I can specify a name and description for it. Unlike other programming languages, in GraphQL, arguments are matched up by name. And in the resolver, I can get the ID or the ID argument and its value using the context object and the get argument method in it. And then I can pass it on to my repository methods to get the ID, get the student or the course by ID. So when you consume such a GraphQL query, you can pass variables as a separate dictionary. So for that, you need to define variables, and a variable is defined like so using the $sign in GraphQL. You need to specify the type for it, and it should match the type that is specified in the actual query. So in my student, it is a non-nullable int. If you mark it as just an int, it won't work. And then I can specify my operation, and against the argument of the query, I can specify my variable, and then again ask for the fields that I need. And to pass in query variables, I can do it as a JSON dictionary like so, and that should get me back the student details. So the variable name is the JSON key here, basically. Now you have seen there's related data that I'm querying in here, and there's a technique called data loader in GraphQL, which helps you fetch related data effectively. You can use entity framework, repository, and for each of the student, get the enrollment details. You can do it that way, but it is not super performant because what it does is it first gathers all the student IDs, and for each of the student ID, it tries to go and fetch the enrollment details. Again, we have the N+1 issue there. To overcome that, GraphQL has this concept called data loader, which is like an in-memory cache. What it does is the first time the enrollment details or the related details for a student is asked for, it fetches all the enrollments at once using a batch operation and holds that in memory. And it holds that in memory using an object which can be looked up. And the next time a student detail, a related detail is asked for, the data is fetched in from the data loader. So to set up data loader, you need some spicing in the startup class, which is why you have the add data loader here. Once that's in place, in my Contoso University query, it's in my student type, I can inject the iData loader context accessor, which helps me have an instance of the data loader accessor. And when I have the field where I need to resolve the related data, enrollments in this case, in the resolve method, I can specify or use the get or add collection batch loader. This helps me batch load a list of enrollments for all the students from the EFCO database. Again, the object that is held in memory should have a name, and that is specified here. And let's go have a look at this repository method. What it does is it returns a list of iLookup objects. With every student, you can have multiple enrollments, so which means a dictionary cannot help in this case because dictionary can have only one value against one key. With iLookups, we can have multiple values against a single key. So I am getting all the school enrollments for a list of student IDs that has been passed in, and then converting to a lookup object and returning back. And when a student ID's enrollment is asked for, I can load it from the data loader like so. The context object, which gives you the context of the query, has a source property, which gives the parent object in the graph, which is student in this case, and I can access the ID from there on and pass it on. So that's data loader. Now let us see how this can be consumed in my Blazor app. So this is my Blazor app. It's plain and simple. I have a page to load the student details. I can click and go into and see the details. And I have courses details. So we'll have a look at the students and the student details page for this and then move on to mutations. So in my Blazor app, I have this component called students. It's a routed component, so I have a route template for it. I can inject the iGraphQL client, which helps me make the calls. And in the code, I have specified my query. It is similar to what I just showed you in the test. I have an object to hold the deserialized information that comes back from the GraphQL query. And to show this data on the Blazor component, we can make use of one of the lifecycle methods. So on initialized async method, which is the second lifecycle method in Blazor, helps you initialize the data for a Blazor component. So in that method, I'm specifying a GraphQL request object and specifying my query. And then I am sending this GraphQL request off to my endpoint using the send query async method. This does a post to the endpoint and gets me back a GraphQL response object. The GraphQL response object has a data property, which actually is the deserialized data that you see inside here. And I've got this class for that. I'll let you have a look at it. And I can then assign my response.data value to my students object here. Because it's an async method, I need to check for null before I loop through and display it. So that is the student details, student data, sorry. And if I click on this, I can see the student details along with the enrollments. So as you can see, there's a bit of parameter here, which is basically the ID of the student. So let's have a look at how I achieved that. So again, I have a component called student details with a route template specified with a route parameter. I've constrained it to be an integer type. So that's a route parameter. and I'm consuming that in a public property like so. So the way you consume parameter in Blazor is using a public property of the same name as the parameter, and then by assigning or adorning it with the parameter attribute. I have the same query which I showed you before specified here. Again, I have an object for deserializing the data. But when it comes to displaying the data, we have a bit of a hiccup here. Blazor is a single page application framework, so which means that the component, once loaded, it doesn't reload unless you force it to load. We don't want that. But we have a third lifecycle method called onParameterSetAsync, which runs every time a parameter is set. So that's the case that we have here. Every time the parameter changes, the ID value changes, we need to reload the data. So all my data loading happens in this particular lifecycle method. So I'm specifying a GraphQL request and passing in the query. And the variables can be sent as a separate dictionary. So I'm setting up an anonymous dictionary. And this ID corresponds to my variable name here. And I'm passing in the ID, which comes in from my parameter property here. And then I'm passing on the request, again, using the sendQueryAsync method, getting the data back, and then checking for nulls, and then displaying it. So that is all about queries, a quick rundown. Let's now talk about mutations. So mutation is the top level entry point for write operations. And again, it happens over an HTTP post. Mutation keyword is the keyword for sending in the mutation query. And mutation always accepts an argument. It accepts an argument of input type, which is again a special GraphQL type. And the fantastic thing about GraphQL mutation is that you can query what comes back because what comes back is a graph type as well. So if you're creating a course, you can send back a course graph type which you have just created, and the client can use that for further processing on the front end. But unlike queries, mutations are always executed in series, one by one. So let's look at how we can enhance the schema and then go about setting up a mutation and consuming it. So we'll use the course for that. We'll create a mutation around course and then create a course as well using the Blazor app. So again, I have the mutation operation specified here, and I'm getting the mutation Contoso University mutation object. The mutation is again an object graph type. It's a class which inherits from object graph type, and I'm injecting all my repositories here. And again, being a graph type, it has fields. So I have specified fields for creating a course and creating a student. If you want to extend it for updates and deletes, you have to add corresponding fields and resolve it as well. So each field has a return type. So what I'm trying to do here is when a course is created, I'm sending back the course type as the graph type, which again, the client can query. I have a name for my field, which is create course, which will be the name I use for my GraphQL call. And the argument is a non-null graph type of course input type. And it again has a name because arguments are matched by name. So let's have a look at this course input type. The way you mark input type in GraphQLnet is by inheriting from input object graph type. This tells GraphQL that this is an input type. This is to be used as an input type. And I'm using it and I'm sending it the base course entity type as well. And in my constructor, I can define a name and description for this particular type. And again, I can specify my fields for each of the input or each of the properties in my base entity class. I can set the nullability. I can give it a name if needed, which again gets picked up and can be used in our queries as well. And the description, which again enhances the documentation. So that is the input type. And then we can look at the resolving part of it. Again, I can get the course from the course entity from the argument. And then I can pass that course into my entity, my repository, which again does a bit of entity framework magic and inserts the course into the database. We'll come back to it, the subscription part. And the course that I just created, I'm returning back to keep things simple. So let's have a look at the course in the IDE first. So to send a mutation, the keyword that you use is mutation, followed by an arbitrary name for your operation. Again, I have a variable defined here, a variable specified here, again with the type specified. In my docs, I can see the mutation, so I can always understand what the course input type is all about from here. And then I can start with my actual create course operation. So the course is the actual argument which the operation needs, and I'm setting the value of the course argument to be my variable value. And then from the graph type that it returns, which is the course type, I can query the ID, credits, and title. And if I have to pass the variable value, I can use a bit of JSON like so here. So have a course object with ID, title, and credits. Let's just add a course here. And that has been added. So now let's go and see how this is consumed in Blazor. I have this add course field Blazor component here, and I'm using the form component to do the work. So once a form is submitted, I need to see a bit of messaging here. It's a very simple form. So in my Blazor component, I again have a route template and inject my iGraphQL client. I'm using the standard built-in form component from Blazor for the form. It needs a model, which is like the view model for your MVC form. If you can compare with that, it is quite similar. And it needs a handle for handling valid submits, which is again a method that I've specified. The course model is an add course model, which I've defined here, which is literally a simple POCO with ID, title, and credits. And each of the property is bound to one of each of the form fields. So input number, input text, and input, the third one is actually built-in components from Blazor for input number and text values. And the bind attributes helps with two-way binding. So whenever the value of the field changes, the value gets bound. And because it's all attached to the model is always up to date. And I'm showing a bit of messaging here when the form submission is successful. I have an object to hold the deserialized information. That is the graph type that I'm returning back and querying. I have a bit of string text to help me with the messaging. And that's my mutation query specified. And in my add method, I again start off with a GraphQL request, specifying the mutation against the query. That is the string query. And I'm setting the variable as a dictionary again with the variable name course. And I'm passing in the entire model that I have here as the value of the variable. To send a mutation, I'm using the send mutation async method, which does the GraphQL API call and gets back the response. Again, a GraphQL response. And I can use the data field, which is holding the deserialized information and checking for null to show the message. Sorry, and I need to reset the form when the submission is complete. So I'm setting my model to a new instance again, which resets the form for me. So let's go and see whether this works. 1003, course 1003, and 5 credits maybe. That's course added. If I go in and have a look, that's my course added. So that's mutations, a quick rundown. Subscriptions, these stand for pushed updates. Unlike situations where the client polled for updates, this works the other way. Updates are always pushed from the server, and clients can choose to listen. I believe in GraphQL, this work over WebSockets. Again, it's an HTTP post operation, and the subscription keyword is used. Unlike the query and mutation, subscriptions are stateful. They need to have an understanding of what clients have subscribed and what data is there in place so that it can then relay that back to the clients which have subscribed. We have a little bit of setup to do with subscriptions. We need two packages, one for the API, that's the server side, and one for the client. And the first one is the subscription WebSockets, which needs to go in my API. And then I need the WebSocket in my client as well. So let's have a quick look at all of these. The first point is the startup, where I need to register the service and register the middleware as well. So add WebSockets registers the WebSockets for me. And in the middleware, I'm setting up the WebSocket middleware and also the GraphQL WebSocket middleware, passing in the Contoso University schema. That is the base setup done. And the scenario that I'm trying to show you is when you create a course, that is send a mutation in, it sends a message back to the clients that are subscribed saying a new course has been added. So the way it works is when a course has been added, it sends a message to somewhere, and that message keeps track of an object, and that particular service sends back a message via the subscription to the clients. And this is all system reactive namespace work, which I will try to explain to my best of the abilities. So to help us with that messaging service, we have a course messaging service, which is here. So the course messaging service has a private message stream field, which is an instance of iSubject. So from my understanding, iSubject is something which implements both iObservable and the iObserver name interfaces. So which means it's something which can keep track of itself. So that can be observed and that can observe itself as well. And replace subject is like an implementation of an iSubject, but keeps in cache what has been previously added for a short amount of time as well. So when a mutation is sent or when a course is added, it sends a message to this add course added message. And it sets up a new object called course added message, which is literally an object with ID and title. And then that message object is added to the message stream. This then gives the latest object that's been added to the message stream and sends that message back. And the subscription in the schema subscribes to this particular message stream using the get messages, because the message stream is returned as an observable, so the subscription is constantly watching it. And this message service needs to have a lifetime during the lifetime of the application. So this service needs to be set up as a singleton in my startup. And finally, to the schema where I have to enhance it with the subscription. I have the subscription here. And I'm adding the field in a very different format here. It's an event stream field type that I'm sending back. It again has a name and a type. The course added message type is again a graph type based on the course added message. Let's just speak the definition here. It has a ID and a title. It has a resolver, which makes use of a func field resolver to cast the source as a course added message. And this is the subscriber which subscribes to that message stream and keeps track of it. So the subscriber gets the information and then it passes on to the clients who have subscribed to it. So this is the subscription part. We finally need to let the message service know that a new course has been added. That is done in the mutation of the, sorry, not the mutation, the course type. Sorry, mutation. When a course is added, I am awaiting it, making sure the course has been added, till I send a message to the service saying a course has been added. So the message then adds it to the message stream, and the subscriber, which is keeping track of the message stream, gets the message and then relays it to the clients who have subscribed. So let's see this in action in the IDE first. The keyword is subscription. I can send in an arbitrary name. The course added is the name of my subscription. Again, it can be viewed in my docs here. And I'm asking for the title of the newly added course. So when I click here, it goes into the listening mode. So if I add a course here now, it will add it. Sorry, it did not. Let's add some. There we go. It was the ID. It's not database generated. It keeps track of it and returns me the title as well. So if I show this again, Uh, it should give me the latest one I added. So it's the replay subject which keeps track of it and constantly displays things for me. Now, how do I consume this in my Blazor app? So on my Blazor, on my courses page where I display the details, I want to make sure I get an update when a course is added, and it also refreshes the table for me. So for that, in my component courses, where I load the data in my own initialized async method, I also send a subscribe request. For that, I have a subscription query, which I just showed you defined here as a string. And in my subscribe method, I'm setting up a new GraphQL object with the query here. And I'm sending a subscription message using the create subscription stream message. This creates a subscription stream, and it's an IObservable object, so it keeps watch of it. And then I have a watcher for the IObservable messages. So when I receive the messages, this keeps a watch on the IObservable, and the response which I get back is a course added type, which has an ID and title, and I'm using the title to display the messaging. But I want to refresh the table as well, load the data again. So I call my load courses data again, which does the call to reload the data. But the app doesn't have a context that it has received new data and it needs to refresh. It is usually not a problem when you have an event taking place, like a button click or parameter changed. But in this case, we don't have that context. So I'm using the state has changed method, which is like a built-in method in Blazor, to force the reload of the component explicitly. And that does the work for me. So let's have a quick look at the updates here. Let's see whether this does the work for me. So I'm sending in a course again with, say, ID 15560, maybe. That's my course added. I get the message here, and it's also refreshed my table for me. So this is a quick rundown of how we can create an API and consume it. There are some advanced techniques which I haven't demoed today, like pagination. GraphQL supports a cursor-based pagination. There's filtering and sorting, which you can implement. You can have authorization, so you can authorize your endpoint with an API key if you need. You can even have fields locked down with permission. So if you are in the admin role, then you can query a field. I believe GraphQL API from GitHub makes use of that. Caching can be quite funny with GraphQL. The reason being, to cache something, we need a specific URL. With GraphQL, we only have a single endpoint. So caching is not something that is explicitly supported as a specification, but Apollo specifies automated persistent queries, which helps to cache a query and then query it using SHA. Again, it's probably beyond the scope of this talk for the day. You can always also have a microservice style architecture around GraphQL APIs. So you can have 3 or 4 different GraphQL APIs, and then you can collate it together, federate it together, have a gateway, and serve data from there. And it's, in fact, one of the most popular uses of GraphQL. What wins with GraphQL for me? Exact fetching, which means less round trips and less network usage. We have loosely coupled client and server because of the way because a client always gets the control of the data it asks for. The auto-generating API documentation is fantastic. GraphQL API is version free. And then you have the ability to lock down field by permissions. And what the downsides are, the caching complexity, file uploading can be tricky. You can base encode it and upload it, but again, that results in a huge payload. Again, file uploading, I don't believe it's something that is defined as a part of the specification. And with nested queries, you could, a little bit of carelessness and you could result in bringing out the entire database, which is not really good. But you can overcome that by specifying the query depth. So you can limit the depth of the query that the client can ask for. And finally, there's a learning curve around GraphQL as well. It's a totally different paradigm shift from REST API if you're used to REST API. I have collated my demo and all the notes around both GraphQL.net and Hot Chocolate into this bit.ly URL. It takes you to my blog where I have a little write-up of GraphQL with all the resources for the day and the demo I have put together for the day. So that is it from me. I hope you learned something. Thank you.